Hey guys, welcome back. We now know the basics of HDFS. We know all files will be divided into blocks and will be replicated 3 times by default across the nodes in the cluster in HDFS. In this lesson, we are going to just talk about blocks. You're probably thinking, what is so special about them that we need to dedicate a whole lesson to it? Actually, there is quite a lot of interesting things about blocks. Let me first show you something. I'm using Windows operating system in my laptop. I'm going to create a very small text file. The text file, I'm going to name it as test.txt. And then I'm going to add just one word into the text file. Save the text file. Now let's right click and click the properties of the text file. Take a look at this right here. The size of the file is 4 bytes. That's it. But the size on the disk for this file is 4 KB. I'm sure you have probably seen this before many times. But can you answer why the file is taking 4 KB on the disk when the actual size of the file is only 4 bytes? Any guesses? Because 4 KB is the block size or cluster size of the operating system in my laptop, which is NTFS. So 4 KB or multiples of 4 KB is the minimum amount of space that the file system will assign to a file. So if the file size is 2 KB, it will still take up 4 KB on disk, leaving the 2 KB unused, and this 2 KB cannot be reused for anything else, leaving them unused forever. If the file size is 8 KB, it will take up 8 KB, that is 2 4 KB blocks. If the file size is 13 KB, it will take up 16 KB or 4 blocks, leaving 3 KB unused. Again, this 3 KB cannot be reused, leaving them unused forever. So, 4 KB or multiples of 4 KB is the minimum amount of space the file system can assign at any given time. Why this information is important? Now, answer this. Let's say the configured block size of your HDFS in your Hadoop cluster is 256 MB. Let's say you uploaded a file which is 1 MB in size. Does HDFS still allocate 256 MB, leaving 255 MB unused? That's a great question, isn't it? I love to ask this question in an interview. Most of the time, I get correct answer to this question. However, I don't get a good answer for the follow-up question that I ask right after this question. Before we go to the follow-up question, what do you think is the answer? Do you think HDFS will allocate 256 MB to store a 1 MB file, leaving 255 MB unused? The answer is no. That would be a lot of space wasted. From our HDFS Why Another File System lesson, we know that HDFS is not a replacement to the local file system, and all the blocks are physically stored in the local file system. Even though the file uploaded to HDFS is divided into blocks, these blocks are stored in the hard disk, which is managed by the local file system. Which means, in the hard disk, the file will be stored as per the block size of the local file system. So if you have a cluster in which the local file system is ext4, for instance, and with a block size of 4 KB, to store a 1 MB file, which is 1024 KB, you would need 256 4 KB blocks, which is exactly 1 MB, to store the file in ext4. If the file size is 1025 KB, for instance, we would need 257 4 KB blocks, leaving 3 KB in the last block unused. So even though HDFS has a block size, the space allocated for the file on the disk will still obey the rules of the local file system. Hence, for that reason, HDFS will not allocate 256 MB to store a 1 MB file. Okay, now to my follow-up question in an interview. If the blocks are stored by underlying local file system anyway, why are HDFS block size so huge, like 128 MB or 256 MB as compared to 4 KB of block size in the local file system? Why don't we keep it as 4 KB? To this question, I will usually get answers like because Hadoop is designed for big data sets, and that is why we have huge block size. To that, my question will still be, so what? What is the actual need for a huge block size? Here's the answer. When the block size is huge, the OS will attempt to store the file in contiguous blocks on the disk. If the blocks are in contiguous locations, both reads and writes will be faster because the blocks are laid out next to each other, as the disk head doesn't have to seek and position itself over and over again for blocks, as they are stored contiguously. This is a huge benefit as the read and writes will be very efficient. But it is very important to note that OS will attempt to write big files in contiguous location, but it does not guarantee that. Here's another follow-up question. If storing big files are advantageous in terms of read and write efficiency, why do we have to split the files into blocks at all? Why don't we store the file as a whole? By dividing the files into blocks, we can store data set of any size and not limited to size of the volume of any individual hard disk. From the HDFS Why Another File System lesson, we know that each file system has its own volume limit. For example, NTFS file system has a volume limitation of 16 exabyte. So if you have a dataset which is 17 exabyte in size, you're out of luck. You cannot store that file on a hard disk as a whole, but by dividing the dataset into blocks, you can store the blocks across many nodes in the cluster. Also, dividing a dataset to blocks and replicating the blocks offer redundancy and fault tolerance. Let's say you have a file which is well within the size of the hard disk, and you decide to store the file as a whole instead of dividing them into blocks, and decide to replicate the file as a whole 3 times. Something like this, as you see in the illustration. So now you have one file replicated into 3 nodes, node 1, node 2, and node 3. In an event where all 3 nodes crash, you would lose the file. Whereas, let's take another scenario where you divide the same file into 5 blocks and store each block in a different node with a replication factor of 3. The blocks could be stored as much as up to 15 nodes across the cluster. So to physically lose the file, all 15 nodes would have to crash, which is less likely as compared to 3 nodes going down at once. So to summarize, in this lesson, we understood why dividing files into blocks is beneficial. Also, we understand the difference between the blocks in the local file system and HDFS, and the advantage of having huge block size as opposed to a smaller block size. With that, let's wrap this lesson. See you in the next lesson.